Hi, so today we're working on the notes for weird systems. And really all a weird system is it's a system where one or more of the equations is not a linear equation. So in this case, we're going to be working with linear equations and absolute value equations. All right, so let's do a quick review first of the parts and pieces of a absolute value equation and exactly what these things do. All right, number one was asking us, part A here, to compare the equation to the parent graph, remembering that the parent graph is y equals the absolute value of x. All right, and it has a vertex of 0, 0. It opens up, and the slope of its right-hand side is 1. All right, so knowing all these things, we're going to compare the parts of this equation to the parent graph. Number one, is the opening of this up or down? Well, the opening is determined by the sign of our part A right here, and it's negative, which means that this is going to open down. The stretch also has to do with this A number here, and the stretch has to do with the slope of the right-hand side. So this is -2, which means we're going to open it down. But for clarity's sake of drawing it, I'm going to draw it up. All right, so this means that I start at the vertex. I'm going to go up 2 and out 1, up 2 and out 1. I do the same thing for this other side, up 2 and out 1, up 2 and out 1, right? And we've already said that the slope on our standard graph is 1. So if I started at the same vertex and I went up 1 and out 1, up 1 and out 1, up 1 and out 1. Do the same thing on the opposite side, up 1 and out 1, up 1 and out 1. Do you see the difference? Yeah, this one is definitely way more narrow. All right, last thing we're looking at is the shift. Left, right, up, down. What did it do? All right, the shift, we're looking at these two numbers here. Our -1 here, this is the h part of the equation, and it tells whether we're going to shift left or right, and we do the opposite of what it says. This is a -1, so rather than shifting left 1, we're actually going to shift right 1. And then the k part of our equation tells us our up and down shift, and we actually follow the sign for this one. So it says +7, so this shifted right 1 and up 7. All right, B, what does it mean to be a solution to a system of equations? Well, it means the same thing for a weird system as it does with a linear system. It's a point or set of points bear with me, Smart Notebook's being slow. There we go, set of points. And literally we're talking coordinates here, x, y, that satisfy both equations. So just like when we were graphing the straight linear systems that we did in the last lesson, we're looking for the places where our graphs overlap. All right. In this case, because we have both a linear and an absolute value, it's possible that we have one solution, two solutions, or no solutions. There is also a possible case where we'd have infinite solutions. All right, so let's look at our first couple examples. All right, find the solutions to each of the systems of equations below. In order to find the solutions, we're going to graph them. All right, our first one says y equals 2. I have no x here. So you all remember that a y equals is a straight line, a straight horizontal line. And it's going to cross the y-axis where y equals 2. So that's what that one looks like. Let me grab my green pen. My next one is y equals the absolute value of x. This is our parent graph. All right, which means that we're going to start at our vertex at 0, 0. I said green. There we go. And our slope is 1, so we're going to go up 1, right 1, up 1, right 1, up 1, right 1, and so on. And we're going to repeat the same thing on the opposite side, up 1, left 1, and so on, all the way up to this corner. And then we can draw our lines. Now our solutions are where our two graphs cross, which is right here and right here. In this particular graph, we cross in two places, so we have two solutions. So let's write down the coordinates of this. This is -2, 2, and this is +2, 2. Once again, I remind you, be very, very careful, super duper pay attention to the negative signs, all right? Because this coordinate and this coordinate look very similar. The only difference is the negative sign on that y coordinate. They are not the same point at all. Pay attention to your negatives. All right, let's go back to our next one. Y equals the absolute value of x minus 4. All right, so we need to start at our vertex, which we know is not going to be 0, 0. So first we see, did we shift left or right any? That's what's inside with the x. Nope. So my x coordinate stays at 0. But my y coordinate, I went down 4. So my vertex here is at 0, -4. So 0, -4. 1, 2, 3, 4. All right, my slope here is 1, and it's a positive 1, so I'm going to open up. So I just plot it like this. Up 1, right 1, up 1, right 1, and so on. Right? Go back to my vertex, and I go up 1, left 1. Right? And then we could draw our lines. Ideally, you want to have a ruler to do this because you want your lines to be very much as straight as possible. All right, next, we're going to graph our next line. This is just a linear. So we start at our y-intercept, which is -1. Then we use our slope, which is 1/2. So up 1, right 2. Up 1, right 2. Up 1, right 2. Up 1, right 2. Then we go down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, and so on. And then we draw our lines. All right. So where we cross was right here and right here. So what are these coordinates? Well, this one is -2, -2. And this one is 1, 2, 3, 4, 5, 6, 2. So those are my solutions. All right, you guys starting to get it now? We're just graphing them on the same graph and then going from there. All right, next one. I've got an absolute value equation and I have a linear equation in standard form. Easiest way to graph this is actually just to convert this guy into slope-intercept form. So let's do that. I get 2y equals -x plus 10. If I subtract x from both sides, divide both sides by 2. So I get y equals -1/2 x plus 5. Let's graph that. Start with our y-intercept, which is 5. 1, 2, 3, 4, 5. Use my slope, which is -1/2. So down 1 and right 2, down 1, right 2, down 1, right 2. Go back to my y-intercept, do the same thing on the opposite side, up 1. Sorry, do the opposite thing on the opposite side. Up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2, up 1, left 2. And then we draw our line. Because I said, ideally we have a ruler. We're just going to have to make do for right now. All right, next, graph our absolute value. First, let's find our vertex. This says go right 2. This says go up 4. So my vertex is at 2, 4. So let's graph that. 2, 1, 2, 3, 4. Ooh, hey, we intercept. That's great. All right, and then my slope is -3, 2. So that means I'm going to start at my vertex. I'm going to go down 3, 1, 2, 3, and right 2. Down 3, 1, 2, 3, and right 2. Go back to my vertex and do the same thing on the opposite side. Down 3 and left 2. Down 3 and left 2. And we could keep going. Draw my lines. And this one, we only intercept at 1 point. And what's the coordinates at this point? Well, it's 2, 4. All right, let's graph our next one. Once again, we're going to convert this to slope-intercept form. So -3y equals -x plus 6. Divide both sides by -3. So y equals a +1/3 x minus 2. graph it, start at my y-intercept, which is -2. My slope is 1/3, so up 1, right 3, up 1, right 3, up 1, right 3, down 1, left 3, down 1, left 3, down 1, left 3. Draw our line. Then we're going to use our absolute value. Our vertex for this one is -3, 1, -3, 1. Our slope is 1/3. So once again, up 1, right 3, up 1, right 3, up 1, right 3, up 1, right 3. Back to my vertex, up 1, left 3, up 1, left 3, and that's as far as I can go. So what's my solution? Well, they don't intercept, do they? Right? Looking at this, we can tell why they don't intercept. Do you notice the slope of my linear equation and the slope of the right-hand side of my absolute value are the same? So this line and this line, they're parallel. So there is no solution to this one. All right, let's flip this page over. And we don't have anything on the back, but I want to discuss with you. Remember I said we could have one solution, we could have two solutions, we could have no solutions, and we could have infinite solutions, right? So you've seen the examples of the other ones, right? So absolute value with a line that runs through it, this has two solutions. A line with the absolute value that intercepts it just at the vertex only has one solution. We just saw one that had no solutions because one of the sides were parallel. So what do you think one looks like that has infinitely many solutions? Well, just as with a regular system, it means that two of our lines are going to have to overlap each other. So if I've got an absolute value and then a linear comes right on top of one of the legs, that would have infinite solutions. This does not happen that often. So if you're getting one that looks like this, double check yourself. Make sure you did it correctly. All right, that's all we have for today. As always, send me an email if you have any questions. Good luck with your homework.